In the words of Doc Brown, please excuse the crudity of this model. I didn't have time to build it to scale or to paint it. Okay, now we're going to play with the actual shadow, what it does with the light source behind the moon that's eclipsing the Earth. And you can see that we've already got a partial eclipse where we're set up right now. And she's going to move 15 degrees and I'm going to move 0.5. Okay, go. Okay, go to the next one. Another 15. And that's it. And as you can see, maybe this angle's bad because I can't see. Yeah, this angle's probably bad. We'll have to try the other side. Okay, we're going to try this angle here, and she's going to move 15 degrees an hour, and I'm going to move 0.5. Okay, go to 15 degrees.
Okay.
I'm at 0.5. Go again.
Okay.
0.5. Go again.
Okay.
0.5. And as you can see, that shadow is not doing what it should do according to what it's going to do on eclipse day. Okay, so here's the other thing I wanted to point out too, is when you have that eclipse happening, I don't know why the shadow is very, very large on my model, but it's going to be very, very small by comparison in real life when it happens. And then I wanted to see if I could capture. I can't quite make the corona, but I'm using artificial light, so it's difficult. And I've got a lot of reflection off of my floor. Okay, now let's get into how we arrived here. Okay, so this is going to be a video about the upcoming eclipse, and I'm going to try to replicate the shadow moving across the Earth. And anyway, we'll see what happens. My scaled down version of the Earth and the Moon and the distance I came up with to try and have it to scale. And all of that math right there, if you want to take a look at it, go for it. And I came out to about 25 feet from my model Earth, which is about 10 inches. My scaled down moon and Earth, and at the correct scale distance, which worked out to 25 feet, if I wanted to scale the sun, it would be out my back door almost 2 miles. That's the absurd distance that the sun is. I think this distance here is already absurd. Okay, so this is my math that I calculated out for the degrees per hour of each orbit and each rotation of the Earth and orbit of the Earth around the Sun, which I don't think is going to play any kind of a factor in this because the Moon and the Earth move together around the Sun, so they move together. So I don't think that angle is all that important, but these two angles are important. And I'm going to show you what that looks like with the model I have on the floor. Okay, so here's my modeled moon and distance to Earth, which is about 25 feet. And there's my model Earth, and I have another model moon there because we're going to get this a lot closer later because that distance is ridiculous to try to create a shadow. So that's the distance I have at 25 feet, and the moon's way back there. For this part of it here, I used a protractor on the floor, and I marked off 15-degree increments there because that's 15 degrees per hour of Earth's rotation. And then we took a string line. I've got a string line there with a stick and another, and it goes all the way over there. And we took that string line and we ran it off of that center point there, and then we worked out half a degree, and then 1 degree, and then 1.5 degree, then 2 degree, then 2.5 degree, then 3 degree, and we ran it out to there, and we marked it off on tape. And I did it here too. So there's my increments there. And then out here, oh, by the way, that increment worked out to 2.5 centimeters per degree. And out here it worked out to just over 8 point something centimeters, almost 9. And you can see that the degrees that this moon actually moves per hour, it's barely moving. My degrees of movement of the moon out this far away from the Earth, which isn't very far, is about 1 inch, and for my scaled version, I should have did it in inches and not metric and centimeters. Out here it worked out to be about 3.5 inches per degree of movement that the moon moves. Okay, so this is going to be my degree test with the moon way over there. And forgive the crudity of this model. I didn't have time to build it to scale or to paint it properly. But it's pretty close. It's close enough. So what I'm going to do is I'm going to demonstrate how much the Earth moves and how much the moon moves on its orbit. So I'm going to point that down, and then I'm going to twist this thing here to 15 degrees. And that's about 15 degrees. And I'll just pull this up here and I'll show you what that looked like. I was back here at 0. So we're going to go 15 degrees like that. That's 15 degrees in 1 hour. And then I'm going to turn this around that way. Okay, move that moon, that half a degree that it's going to move. And that's it. The moon moves half a degree per hour. So I'm going to come back over here and we're going to move this again, another 15 degrees. So point that down so you can see it. And then we rotate that thing like that. And that's 15 degrees. And then I'm going to turn it back the other way. We'll look at the moon. Okay, move it another 0.5 degrees. Okay. And then we're going to look back here again. And we're going to do it again. And that's 15 degrees, and that's over the course of another hour. And then move the moon. That's another 0.5 degrees. So as you can see, that moon moves really slow in comparison to how fast that Earth spins. Even out at that distance, 0.5 degrees isn't very far by comparison to how much the Earth actually spins. So I'm coming to the conclusion that that shadow of the eclipse, if the moon is causing it, should go from east to west, just like a sunset. And I'm not sure why it's not. Either the model is wrong or something else is causing the eclipse. So I'm going to do this from the other angle now. Okay, now this is from the moon's angle, and I'm zeroed out here. Looks like we're 0. Hang on, I'll zero it. That looks 0. Okay, and you can see the continent there. I haven't, you can see the continent there. Yeah, there you are. Okay, zoom back out. And now I'm going to demonstrate to you 15 degrees per hour of the Earth and 0.5 degree movement of the moon. Okay, 15 degrees of the Earth. Probably grab it at the base. That's 15 degrees?
Yep.
Okay, and then the moon will move 0.5 degrees, which is right there. Okay, go another 15 degrees. You there? Okay, and then the moon would have moved another half a degree. Okay, go again. And then the moon goes another half a degree. So as you can see, that continent over there, so we got behind the moon here, that continent over there has moved off quite a bit in the wrong direction for that shadow to go. All right, now we're going to do a scaled down version of the distance because this distance is ridiculous and it'd be easier to show you if we were closer. All right, we'll move on to the next one. Okay, now we'll try our exaggerated scale where we're closer, where we can actually see the Earth because we're not like a bazillion miles away from it. And we move the degree increments closer because they would be closer if the moon was that much closer to the Earth. And we're going to demonstrate this again. Okay, so move the Earth 15 degrees. Okay, and then the moon would move half a degree, and that's it. Okay, another 15 degrees. And then this goes another half a degree. Okay, 15 degrees. And then a half a degree. And that's all we have for movement. That's it. So at this distance, you can see that that shadow should go from east to west, not west to east. Okay, I'm going to do this again just so you can see the degrees that I'm moving the moon. So I put the moon just ahead of my degree tape I have there marked off. And 0 is right at the center of the moon's axis there. And I've got the Earth centered back at 0 axis over there. Okay, move the Earth 15 degrees. That's 15, and then we'll move the moon half a degree. Okay, move the Earth another 15, and then move the moon half a degree, and then move the Earth again 15, and then we'll move the moon again a half a degree, and that's it. That's what we have. That's what's going on. So I really don't think that the moon is causing that shadow on the eclipse, or there's something wrong with this model. I don't know. I don't know why it doesn't seem like it's going to work out. That moon shadow, according to this model, the way that it works with how the moon moves and how the Earth moves, that shadow should go from east to west just like a sunset. Why is it going the other direction is the question. Earth rotation outruns the moon's orbit. That's what I'm trying to point out in this video. That I don't believe it's possible for the moon to cause the eclipse in 4 minutes with how fast that moon is moving across the sky, going across the sun. Unless the moon is a lot closer and moving a lot faster, but that can't be true either because the eclipse starts on the west side of the sun and moves to the east side of the sun, which indicates that the moon is moving in the wrong direction. So I don't know why it appears the way that it does. Either the model is wrong or maybe there's something else that causes the eclipse and it's not the moon. I don't know. I'm going to try to move the moon at the same time that the Earth is moving just to show you when they move together. Okay, start moving the Earth 15 degrees.
There.
Okay, another 15.
There.
Okay, another 15.
There. Ooh, off a little. You're gonna have to do that again. It's getting stuck on.
Okay, let's try this again with moving the moon and the Earth at the same time. Okay, go 15 degrees.
There.
Okay, go another 15.
There.
Okay, go another 15.
There.
So, I don't know what to think on that. My conclusions are, in order for the eclipse to happen with the moon causing it in this model, either the Earth has to slow down so that the moon's orbit can appear to be much faster than the spin of the Earth, or the moon's orbit has to significantly speed up and overtake the Earth's spin, or something else is causing the eclipse. So either this model is wrong or there's something else that's out there that we don't know about that's creating the eclipse, or maybe this model's just wrong. I don't know. Anyways, this isn't the format of my content. I don't focus on stuff like this. I'm only interested in it because that eclipse is coming up, and I did hear that the shadow is going from west to east, and in my brain, that this model just doesn't work to make that shadow go that direction. That's why it did all of this. But anyway, if you want to see car repair content and car modification content and innovative inventions that I've come up with, like heater units or modifying a wood stove or creating an oil burner or compound turbo setup on a car, please hit like and subscribe. You won't see much of this content on my channel.